Now children, the measurement of elasticity on a linear demand curve is represented in the geometric method. By definition, we understood that the price elasticity of demand is the change in quantity due to or with regard to the change in the price, that is delta Q by delta P. That gives the ratio of the price to the quantity. Therefore, the price of elasticity of demand depends not only on the slope of the demand curve but also on the two factors, that is the price and the quantity demanded. The elasticity, hence we can say, varies along the curve as price and quantity keeps changing. So the slope of the linear demand curve is always constant because on the line the slope remains the same. However, the elasticity at different points on the demand curve would be different. When price is high and the quantity is small, the elasticity is high. The elasticity becomes smaller as we move downwards towards the curve. Now, given a straight line demand curve in figure 6 above, the curve is small t, capital T, T to T. The price elasticity at any point R can be found by the formula capital R capital T divided by capital R and small t. Otherwise, lower segment divided by upper segment. Using this formula for any point Q or R or S on the curve TT, the point elasticity could be easily found out. So, in the figure 7, you have various points there. Elasticity of demand in point number ED, like you have various points which the point is not mentioned over there, but you have the quantity as on the x-axis QT, OT and OP, the price. Now the various point you have the elasticity of demand which goes on increasing from 1 to greater than 1 and infinity on the upper segment and less than 1 and equal to 0 in the downward segment. Now the next topic, we move on to arc elasticity. What is arc elasticity? We often calculate price elasticity over some portion of the demand curve rather than at a single point in arc elasticity. In other words, the elasticity may be calculated over various range of prices, over various difference in prices. When the price and quantity changes are discrete and large, we have to measure elasticity over an arc in the demand curve. Now here, please look into the figure 8 in page 2.29. Now the quantity demanded on the x-axis is shown as 2 points Q and Q1 and the price is OP and OP1. The price at OP, the quantity demanded is OQ. Now the price when it reduces to OP1, the quantity demanded increases to OQ1. So these 2 points are A and B, the intersection of the vertical and horizontal line. Now when a demand curve DD is drawn joining these 2 points, you have 2 points A and B, and if you have to find out the elasticity in between these 2 points A and B, now here we have a confusion as to which quantity is to be taken as the base, whether the OQ or whether the OQ1. So instead we take the average. Hence the formula becomes EP is equal to Q2 minus Q1. Q2, whereas now here let me first explain as what is P1, Q1 and P2, Q2. P1 is the original price, Q1 is the original quantity, whereas P2 is the new price and Q2 is the new quantity. Now Q2 minus Q1 is original quantity is to be deducted from the new quantity divided by the average of the quantities. Q2 plus Q1 divided by 2. The entire is to be divided by original price minus the new price, P2 minus P1, divided by the average of the prices, that is P2 plus P1 divided by 2. So finally you get the formula as Q2 minus Q1 divided by Q2 plus Q1 into P2 plus P1 divided by P2 minus P1. So in the example earlier, in the headphone example that was given, when the price was 500, the quantity demanded was 100. So let me say it to be P1 and Q1. That's been explained in the page, and I'm just giving you a verbal explanation of the same. Now the price decreases to P2, that is from 500, it decreases to 400, and the quantity increases from 100 to 150. Let us substitute these values in the formula that has been explained in the previous step. Q2 minus Q1. Q2 is 150, change in the quantity, minus the previous quantity. 150 minus 100 is 50, divided by the total of these two. 100 plus 150 gives you 250 into the price of the two added put together, 500 and 400, 900, divided by the difference of P2 minus P1, that's 100. So 50 divided by 150 makes 1 by 5 into 9 by 1. So it's just 9 divided by 5, which gives you as 1.8. The arc elasticity will always be somewhere in between the 2 points. So when it is calculated at between the lower and the higher prices, it need not be in the middle, but it might lie either closer to A or B. That is what is explained in the diagram figure 8.